If you understood example 3, example 4 is almost no different. Now it literally says solve the equation. Here we built equations. So instead of building our equation and solving, now they're already equations. Now we're solving, and we're going to solve these by rewriting. So we have log base 5 of x equals 3. As an exponential, base to the other side of the equals makes that 5 cubed. And that's going to equal x. Okay, we've already done 5 cubed. 5 times 5 times 5 is 125. So we get x equals 125. Now, last time we didn't solve, or we didn't circle or box our x, but now we have equations we are solving. So now x equals 125 is my answer. Same thing here. We have log base x of 16 equals 2. So base to the other side of the equals is x squared equals 16. When you take the square root of both sides, we get x equals 4 and negative 4. Now, I don't think you're going to have a question like this in my math lab because we haven't gone over the domain of logs yet. But in case you do, you can get extraneous solutions here. When you plug in 4, you get log base 4 of 16. That will give me 2. And I went ahead and put that in the calculator since we're not supposed to know how to put that in yet. Okay, so that's fine. When I put in negative 4 for that base, we get an error that is a non-real answer. That does not work with it being negative 4. So my answer is just x equals 4, not negative 4. Now, how can you figure that out when you don't know how to put that in your calculator yet? It tells us in the definition of a log function that your base must be greater than 0. So that base right there. And actually, even that x right here has to be positive. So you don't want your base or that x, anything inside of that log, to equal a negative number. Okay, you get the same thing here. I can put in a common log. If I do common log of just -1, we still get a non-real answer. So you don't want anything in that log, base or what it is of, to be negative. Continuing on, let's rewrite. Base to the other side of the equals is x cubed. And that equals 1/8. Just like the opposite of x squared is to take the square root, the opposite of x cubed is to take the cubic root. So x equals the cubic root of 1 is 1. The cubic root of 8 is 2. Okay. Or you can just put that all in your calculator. Cubic root of 1/8 is 0.5. Here, if we actually knew how to put a log with a different base in our calculator, we could just get our answer just by here, but we don't. So we're going to rewrite. We have 5 to the x equals 625. Let's see if we can write 625 with a base of 5. So we already know 5 cubed is 125. So what is 5 to the 4th? And there it is. So we can do 5 to the x equals 5 to the 4th. Those cancel. And we're left with x equals 4. We have log of x equals 2. This is a common log, which means there is a known base 10. So base to the other side of the equals is 10 squared, and that's going to equal x. 10 squared is 100. So we get x equals 100. And we can check that one. If we put in our calculator log of 100, that does give me 2. This one we can just put in log of 1,000 is 3. How do we get that? That is a log with a base of 10. Base to the other side of the equals what's left over. Rewrite 1,000 with a base of 10, which is the same as 10 cubed. So cancel, and we're left with x equals 3. On G, rewrite it to start with. Again, base to the other side of the equals what's left over. Now we just have a linear equation here. 3 squared is 9. Subtract your 4 and divide by 3. You get x equals 5/3. And then our last one, rewrite that. That has a base of what? A base of 10. So 10 squared equals x squared plus 1. So 10 squared is 100, minus that 1 is 99. Take the square root, simplify. That is 9 and 11, which is 3 and 3. So here's my pair. So we get x equals plus or minus, x squared means 2 answers, plus or minus 3 square root of 11. Now, on the first one we did, we had to throw out the negative, because when I plugged in that negative, we had a negative within that log. But here, because when I'm plugging in, I am plugging into that x squared, it's always going to turn positive. So you're going to have 2 answers here, because when you plug in the negative, it still is positive within the log.